Okay, that's great. Okay, so let's try and start with today's session, especially for what we call the Design 2020 conference. So our workshop is about innovative business models for additive manufacturing, and like to the Design 2020 conference organizers and obviously the moderator for organizing this session. So Advanced Additive Manufacturing, this session will be presented by Dr. Israt Kabir, my colleague, as well as myself, and I hope you enjoy this session. Israt, can we switch to the next slide? Yep. So this session we will have 4 of us in total. Dr. Busayawan from Brunel University and Dr. Israt Kabir. In addition, we will have Professor Damir Godec from the University of Zagreb. And the 4 of us are the session chairs for this afternoon's session. And we try to organize this session. Hopefully it will be helpful and effective for you. And it's been designed so that we can introduce participants about additive manufacturing process, about the and the current application, and secondly about the concept of business model development and how you can actually use the business model canvas, which was developed by a group of people from Osterwalder and Pigneur in 2010, as well as finally to provide examples of innovative business models from other sectors to give you an inspiration. Okay, so Esma, please. Okay, so how we've broken up the session, obviously the time is in the UK GMT, so just add 1 hour for whichever time zone you might be. It would be likely to be in 13 o'clock, which is now, and 13:05, the next few sessions, and coming up with the introduction. And then the next 20 minutes, next 15 to 20 minutes, we will introduce to you what is advanced additive manufacturing, followed by the application, the process chain, benefits and barriers, and finally we will give you an opportunity to ask us some questions and we try our best to answer them. Okay, so before we go into detail, I'd like to introduce and talk to you more about this very exciting project, 3-year European funded project. It's called Increasing Excellence in Advanced Additive Manufacturing, or what we call INEX-ADAM. It's funded by the European Commission with the objective, which is to establish networking and synergy across 5 partners. So there were 5 of us in total, 5 partner institutions, and being coordinated by the University of Zagreb in Croatia. The University of Zagreb's coordinator, and he's being supported by 4 other partners: Brunel University in the UK, Lund University in Sweden, Mountain University in Austria, and finally IDME in Spain. So the 5 of us work together. We've been working together for the last 1.5 years. It's a 3-year project, and the whole goal is to widen research and also knowledge exchange for the field of additive manufacturing, provide technical assistance as well. Okay, for the next slide in here, it shows again a summary of what we aim to do. We've got the coordinator and 4 of the partners trying to support industries and small and medium-sized enterprises as the key beneficiary or the key end user of this whole consortium. Again, the whole point is to try and facilitate knowledge transfer and to accelerate research collaboration through this INEX-ADAM network. Okay. All right, so this is just an introduction to explain to you where we're coming from. And obviously, these are our contact details. By all means, please contact me, contact them, contact Dr. Lam, as well as Israt Kabir. And I wish all of you good afternoon and enjoy this session. Thank you.
Please unmute your microphone.
Okay, so we have our
colleague Dr. Nam here. So we are all set now to go. So Philip, would you like to describe the technical introduction to the attendees and all of us? Just very quickly.
Okay, hello everyone. My name is Philip. I'm a helper at Design 2020 conference. Just a short technical brief on behalf of Israt for this workshop session. If you want to post any live questions, you can use your chat to ask organizers of the workshop for any question. If you want to share your video and audio, please click on the button ask for sharing so that I can allow you and so that I can give you access to this workshop so you can share all your questions. If anything necessary, you can ask me in chat for any technical problems. Thank you.
Now I'm going to briefly explain about manufacturing. So I'm going to play the recorded slide PowerPoint presentation to you, and after that I will hand over to my colleague. Let me share my screen. So are you able to see my screen, right?
Yes, it's right. Everything's fine.
Okay. Thank you. Hello everyone, my name is Israt Rumana Kabir. I'm working as a research associate at Brunel University London for the Inex Adam project. The talk includes introduction to the 7 standard additive manufacturing processes and some advancements to date, with some interesting applications in design and manufacturing, the basic additive manufacturing process chain with pros and cons. ISO designated 7 basic types of additive manufacturing processes, which are vat photopolymerization, powder bed fusion, material jetting, material extrusion, binder jetting, sheet lamination, and directed energy deposition. Vat photopolymerization, the first commercialized additive manufacturing technique, uses vat of loaded photopolymer resin, deposits layer upon layer, cured by scanning UV light or laser beam. Advanced system uses digital light projector as a curing agent. In 2015, Carbon 3D introduced a novel concept named Continuous Liquid Interface Production CLIP, used to make Adidas trainer soles. Integrated with digital scanning technology, 3D Systems company produced personalized teeth aligner with a very higher throughput. New desktop machine by Form Labs is using tough engineering resin in tooling applications from this technology. Powder bed fusion involves the spreading and centering of 0.1 millimeter thick of powder layer with a roller in between fusion layers, selectively melt and fuse together, either by laser or electron beam. Well known for printing high-density printed parts with polymers and metals, also known as various names like selective laser melting, selective laser sintering, electron beam melting, or direct metal laser sintering. Recent advancement is increasing productivity about 400%, by increasing layer thickness from 20 micron to 80 micron. Also, multi-laser powder bed fusion system increases the productivity more than 2 times. French 3D printers provider AddUp, collaborating in multi-million research project with American-based research institute to develop novel metal additive manufacturing process using powder bed fusion. The next material extrusion is widely known as fused deposition modeling by Stratasys. Automatically deposits material through nozzle from a wire feedstock. It widely processes different grades of plastic material and very common in use. Now not limited to plastic, but also metallic materials, including H13 tool steel, stainless steel, and chromium molybdenum steel alloy, are used in tooling applications using material extrusion process. Pioneering by Markforged and Digital Metal.
It looks like Israt lost her internet connection, so I'm sorry for the technical difficulties we are having. Please, Dr. Pei or somebody else from the chairmans, can you step in?
I think she's trying to log back in. So.
Hello.
Now we can hear.
Hello, Israt.
Hello. Oh,
Hi.
sorry.
So,
I'm sorry for
Israt, if you have
hi. Yeah, I can hear you guys.
if you have a problem with connections,
You are actually able.
Israt,
I think it's running fine, but I don't know actually because I shared my screen, I was unable to see it. Yeah.
can I suggest that Philip runs your recorded presentation? So obviously you have some problems with the internet connectivity. So you have sent him the presentation, so maybe it's the best way to do it that way. So please, Philip, can you start the presentation?
Yes, I think that we
Yes,
we were somewhere here, so I apologize if we repeat few.
We were at FDM. We were at the FDM technology. Maybe one slide before. Maybe before. Here. Okay. No. Go forward. Go forward.
Material extrusion.
And a few slides more. Maybe one or two slides more. One more. Yes, this one. Here we stop.
Okay. Steel alloy.
Thank you.
In tooling applications using material extrusion process. Pioneering by Mark Forged and digital metal. Researchers in Harvard invented novel multi-material multi-nozzle 3D printing using multi-material extrusion process, which is capable of switching materials at up to 50 times per second, which is faster than the eye can see. Similar to inkjet printer, in material jetting process, droplets of build material are selectively deposited in layers and cured by UV light, usually print polymeric resin. Today's material jetting systems offer multiple print heads on a single machine, enabling multi-material printing. It can print highly accurate models, aiding medical education and surgical planning. X-Jet Company starts printing ceramic material using new nanoparticle jetting technology. Novel research is going on with metallic ink and insulating polymer to print functional parts in electronic application. Instead of material, liquid bonding agent is selectively deposited through a printer head to join powder materials in binder jetting process. It can print wax, ceramic, plastic, and metallic powder materials, requires post-processing to strengthen the green parts. It's successfully used in pharmaceutical industry to print tablet. Higher resolution and scalability are achieved, leading to produce large aeronautical parts. X1 is the leading provider in binder jetting process, launched new machine called Innovent Pro with novel nanofuse binders. Nanofuse binders are inkjet printable nanoparticle suspensions to make more stronger metallic part. It can print above 22 various metals and superalloys. Sheet lamination is a low-temperature additive process. It uses 0.1 mm thin sheets or foils, stacked and joined them together using ultrasonic welding or other lamination techniques. Post-processing and cutting is carried out to create the shape of the final objects. Ultrasonic sheet lamination technique is now used to build up functionally graded parts using varying compositions of multimaterial sheets. Also, computer-aided manufacturing of laminated engineering materials uses the sheet lamination process to form functional ceramic parts. Directed energy deposition. This is a metal additive technology, deposits molten material from powder or wire feedstock on a substrate layer by layer. Laser beam or electron beam or plasma arc is used as a heating source. It is used for both repair and making purposes. This technology is now developed for various metallic material, including aluminium, by Optomec. The first desktop DED machine is made by Additive to make repairing, and printing easier for small, complex parts. Additive manufacturing technologies have shown potential in various applications, including consumer products and furniture design. Because of its design freedom ability, technological advancement, Limelight is producing lampshades. Multi-material printing is used in architecture and furniture design. Here, the design freedom and capability of printing complex structure of additive manufacturing technologies enable a complementary blend in art and architecture by designing and printing buildings, bridges, mullion, not only serving the purpose but also used as decorating elements. The fashion industries also utilize the additive technology in printing fabrics, shoe soles, and other wear materials. Additive manufacturing is also appreciated in many engineering applications, including aerospace, automotive, tooling, and medical. The basic additive manufacturing process chain starts with making a CAD model of the intended object. The computer-aided model is converted into the STL file, which converts the 3D solid model into a surface model, followed by transferring the file to the machine for building or printing. At this stage, the model undertakes a few processes including part orientation, support generation, scaling, nesting for the multiple parts to print, and so on. When machine is set up with required building parameters such as layer thickness, nozzle height, chamber temperature, the object starts to be built automatically. The final product gets ready after some post-processing operation. Additive manufacturing exhibits a range of merits, including design freedom, automation, capable of creating complex structure, customization, fast processing, and shorter value chain. However, this is still an expensive technology for mass production and need to create skilled users to attract the industries. Also, the qualification and certification of the technology, especially in medical and aerospace industries, are also important. Thank you for your patient listening. For further information, please visit our website and feel free to contact us. We will discuss further in the Q&A session, followed by my colleague's presentation in innovative business models for additive manufacturing. Thank you. This is the talk about advanced additive manufacturing and introduction. And can I request Philip to just turn on the video, next video, to talk about innovative business models, please?
Hello everyone, my name is Busayawan. Thank you, Israt, for introducing additive manufacturing technology. In the next part of the session, we will introduce you to the business model development planning tool called Business Model Canvas. Let me share the slide with you. So in this workshop, we will introduce you to the business model canvas. We will also introduce you to interesting example of business model in the field of additive manufacturing and related area. So what is a business model? My favorite definition came from Joanne Margreta, who said that a business model is a story that explains how an enterprise works. Hence, it covers all key aspects of business operation. The most common business model development tool, or the business model canvas, consists of 9 key elements: customer segment, value propositions, channels, customer relationships, revenue streams, key resources, key activities, key partnerships, and cost structure. Due to the time limit in this workshop, we will focus on customer segments and value proposition only. First, let's discuss customer segments, or CS. CS is defined as different groups of people or organizations that an enterprise wants to reach and serve. Customers is the heart of any business model. No company can survive without customers. So satisfying customers is a very important issue in any businesses. For that, a company may group customers into distinct segments with common needs, common behaviors, or other attributes. An organization should decide which segment to serve and which segment to ignore. Once this decision is made, a business model can be created with careful design around a strong understanding of specific customer needs. Next, we're looking at value proposition. Value proposition in the canvas is described as the bundle of products and services that create value for a specific customer segment. As you can understand, the value proposition is the reason why customers choose one company over another. It's either solve customer problems or satisfy a customer need. Some value proposition may be innovative or represent new offer. Nobody else in the marketplace offer these things. Other might be similar to existing solution available in the marketplace, but with added features and attributes that make it easier, perhaps more cost-effective, more affordable, or more convenient for the customer. Now, let's have a look at business models in the field of additive manufacturing. The most common model targeted to a group of people. The first group of customers are people who need access to additive manufacturing technology in order to produce products in a small quantity. For example, startups company, SMEs, entrepreneurs, and freelancers. The second group are service providers who provide access to this technology in exchange for a certain amount of money, for example, fab labs. The machine producers simply sell their products and provide a certain degree of training to service providers who then provide access to this technology to their customer. The next business model also targets 2 groups of people. The first group of customers are learners who perceive additive manufacturing technology as part of their learning experience. For example, primary or secondary school students. The second group are education providers who use this technology to enrich the teaching and learning experience of their students, for example, schools and colleges. The machine producer generally sell their products and provide a certain degree of training to these education providers, who then use this machine to teach their students. The next business model mainly target disciplines in the creative industries. For example, in-house designers, design consultancy or design agency, and engineers who will use this technology to create prototypes or bespoke products for their clients or employers. The machine's producer simply sell their products and provide a certain degree of training to this creative practitioner, who then use these machines to carry out their work. The next business model targets discipline in the healthcare sector, who will use this technology to create bespoke products for their patient. For example, using 3D printing for joint replacement surgery. The machine producer simply sell their product and provide a certain degree of training to this healthcare practitioner, who then use this machine to carry out their work. The next business model targets individuals who will use this technology to create bespoke work. For example, DIYers, hobbyists, craftsmen, makers, and artists. The machine producer sell their products and again provide a certain degree of training to these individuals, who then use this machine to carry out their work. You probably spot the repeating pattern here. It's a way about selling products and a certain degree of training to businesses or individuals. Things start getting more interesting when the machine producer now step into new territories. For example, lay user. More and more businesses explore new possibilities in terms of customization. In the future, they may allow customers to download the design, customize it, and then print it for their own personal use. These people obviously love technology. Otherwise, they wouldn't engage with additive manufacturing in the first place. However, they won't want to go through the same training like designer or DIYer, making things easier for them in terms of using, in terms of maintenance, in terms of taking care of this machine will be the key to success. Things become even more interesting when we print food. Due to the COVID-19 situation, more and more restaurant people in the catering businesses and food producers start to bring machines into their kitchens. Seeing food being produced or cooked by machines rather than human start to become more common, start to become normal, especially for the hygiene, from the hygiene point of view, less chance of contamination. This new group of users are used to working with machines, and there are many high-tech gadgets in the kitchen, for example, the sous vide equipment. However, the current interface and training program may not suit their need. Moreover, the speed of the printing process may have to be significantly increased in order to cope with the speed that you would expect from the restaurant or from the catering industry. Now we have a machine that is large enough to print a house. All the details such as Places to put oil tubes and electric cables could be included in the design. This could make creating a building more efficient and fast, although the machine are likely to be sold to a construction company. All the important stakeholders, such as architect and property developers, must be convinced. For example, architects may have to rethink the way they design the building. And this need not just training, but a change of mindset, which could be very challenging. Additive manufacturing technology could also support educational institutes, such as museum, gallery, library, and STEM or STEAM centers. Nowadays, many libraries already have 3D printer on site. It could help reduce what they call an idea gap. When you learn about something, you want to try it out immediately. Would it be nice if you could test your idea as soon as you finish reading the book by creating it and then printing it out? The process of selling this machine to these educational institutes should be similar to that of selling them to school or colleges. However, these institutes have less control of their audience, such as museum visitors. They may need a lot of guidance on how to support various levels of lay user, such as family, tourists, and general visitor. You need to work with different groups in a different way in order to support them effectively, successfully. Now, this is the end of our presentation. Next, we will start the interactive activity. Before we start, if you have any questions, please let us know.
Israt, please unmute yourself.
Yeah. Thank you, Philip, for playing the presentation. And I think I can ask a request Dr. Lam to take over the question answer session.
I hope you can hear me clearly. And I'm really sorry about all the technical problems that I have earlier at the beginning of the session. If you have any question, whether it's related to additive manufacturing or whether it's related to business model canvas, please let us know before we move on to the next activity within the workshop.
Yeah, and Professor Damir Godec is also here, so he can actually help you to answer regarding additive manufacturing.
Yes, I can answer if there will be a question regarding the technologies.
So how the participants can ask questions through chat box?
Sure, they can unmute themselves and ask, or if they prefer typing in the chat box, that's fine too.
Okay. Is there anybody? Please feel free to ask.
For example, are there any part of the presentation that you would like us to explain further? Can you comment on diversity of the business model in the AM industry? So when I prepare this slide, then I start looking at firstly, different customer segments, because as we say, that's the beginning of all business model. We start with customer. Although we have many different type of customer, we have school, we have colleges, designer, doctors, plenty. But it seems like the business model seems to be exactly the same. You sell the machine, you also, kind of provide some training to them. I hope that in the future, the business model will be more interesting. And this is where we would like to explore with you that why is it always about selling machine? Can it be about, providing services without actually, the ownership of the machine? And that's other way of supporting people. Especially in the future, we might have more lay user, involved in this. One thing I'm really excited is, there is this prediction about, for example, the food and catering industry, that we will see more and more of the plant-based food in the future. And they tend to come in either paste or the powder form, which perfectly, fine with the 3D printer. So, there is a chance that you will see a lot more plant-based food being produced, perhaps using these technologies and other. And that might go into many, different restaurants, different kind of services, which I think would be very exciting. Is it all about decomposing the cooked food or the cooking itself? Very interesting. A lot of this machine still decide to do specific thing, so you still need a lot of people to kind of help them. So for example, you have the machine that you can just put all the ingredient in and then it would just cook itself. But you still need a lot of people to kind of put it in, checking it and plate it up nicely. At the moment, the machine are not capable of plate things up nicely quite yet. So we're not replacing people. We just bring new things into, the mix, which could make things exciting. Are there any other things you would like to ask us? Because in the next activity, we're going to ask you. We have a few questions we would like to ask you.
Maybe I have a question, if it's possible.
Please.
Yeah. Well, for example, mass customization is also one of the powerful tools for making a new business with additive manufacturing. So how can you see this type of a model? Where are the possible areas of application of this tool together with additive manufacturing, mass customization and additive manufacturing hand by hand?
I think it tied in very nicely with the movement in design. I'm come from the design field. In the past, designers tend to design for people, so we try to understand the user and then we design for them. Now we understand that people are individual. They all have different needs, and then we start to design with them. So we start to bring them into the process, and they're helping us design things better. In the next movement, things will be designed by people, and we designer and or the developer just supporting them. We will play the facilitator role. So when you talk about mass customization, this ability to personalize things. So in the future, there's a lot of people who predict that people will be able to design things themselves, but they need help in terms of turn that into reality. Not every people learn how to use CAD software. They don't know how to sketch. They don't know all this visualization too. So in order to help people design things and customize things, we have to make all this tool or this interface as easy as possible. And it will go very nicely with, the additive manufacturing. At the moment, you can download a lot of files from the company and you can edit it. But still, you need to have a specialist software. You have to have a good understanding of things like material integrity, because you might think, oh, I can change this, but you don't know that actually when you print it out, it's going to collapse because you don't understand, all the technical kind of requirement behind it. And in order to make this work, there's a lot of things we have to put in place in order to prevent all this, like a mistake that people might make. Unintentionally, how we could make the tool for editing things a lot simpler, how we could make looking after, all these products a lot easier. For example, in our design school, we put a lot of 3D printer in a design studio and let the student use it. seriously, they clock things up, every now and then. And even this is the trend, like young designer that don't know how to look after this thing. Imagine lay user who will have this at home, for mass customization. We have to make things a lot simpler and easier for them to use. But I think that's exciting place to go. And it might not be just for making new things only. If we look further into the future, in terms of sustainability, remanufacturing things, upgrading things, make certain change to things so that it lasts longer, that could be another area which is exciting too.
Much.
If no further questions, shall we have a tiny break, Israt?
Yeah, sure. If
We did say we're gonna have a bit of a break in the middle. Yeah.
Yeah, and then we can come back for the interactive session, and then we can discuss more together. Yeah.
Shall we say 10-minute break?
So we will have 5 minutes.
5 minutes? Yep, 5 minutes is fine if everyone's okay with that. So we see you again in 5 minutes. Thank you.
Yeah. Okay.
Okay.
See you. Okay. Yeah, we're back.
Israt, if you don't mind, can you share the screen, because the question is on the rest of the presentation, isn't it?
Yeah, I'm ready for that. Yeah, so let me
Thank
share
you.
my screen. Yeah. Can you see all?
Yes, I can.
Okay. So if I just move.
So in the room, if I understand correctly, we have 13 people. That's you, me, Damir, and Phillips. So we have roughly about 9 participants. Am I correct?
Yeah. So we
Yeah.
have 9 participants.
We have 9 participants, so that's great. We can really have a proper chat then.
So
Right.
we invite the attendees to speak if you want. Yeah, and we can only activate 9, maximum 9 speakers in the panel.
Oh, okay.
Yeah,
I
including us.
think like that, since we have a small group, it would be lovely if we could ask, everyone to kind of just briefly introduce yourself, and tell us what you would like to get out of this workshop, so we make sure that we're trying to address your interests, what you would like, what you expect from this workshop too. So anyone care to start? Would you like to just briefly introduce yourself and tell us what you like to get out of this workshop? That would be great.
So shall we start from Damien Mote? You can unmute yourself and.
Okay.
A person who wishes to speak, please click on the button "Ask permission to share" so that I can allow you to speak. Unmute already asked, so I allowed him to speak. Everybody else, please click at the button "Ask for sharing."
Yeah.
Unmute, you can speak now.
I think you have to unmute yourself. Yes.
Am I audible? I hope I am audible.
We can hear you.
Okay. Yeah, good afternoon. Good afternoon, all. So I'm Anumod from SFO Technologies, India. So we basically do a lot of things in additive manufacturing, and what we focus is how we can use additive manufacturing for the bulk manufacturing or the production volumes. So that's the area we are checking it, and we focus more on to that how additive manufacturing can be used for injection molding tools or production tools, and how fast we can make production components in faster lead time. That's what we are checking it. So nice to get your views on different ideas and different options also. So it was really an interesting session for us. I think yeah, after introducing other things, we can get it.
Yep.
Yes.
Thank you.
Okay.
Can you tell us what type of technologies you are using for production of tools for injection molding?
Yeah, currently
are the plastic technologies or with metal? Thank you.
If we try with SLA itself for the plastic, because what we found is like DMLS is costlier, and instead of mill CNC milling machine, if I am going for DMLS, I am not getting any cost advantage, and even that cycle time also we are not getting much reduced. So one thing which we are trying right now is with going with the SLA itself, And you might be knowing there are resins which can withstand up to 300 degrees Celsius and which have good strength. So right now we are making small insert and other things with these type of tools and trying for that, making small volume of production of particles.
Mhm. And can you compare the cycle time when you are using SLA mold inserts compared to the traditional one? Because you can expect a lot longer cycle time in that case, and you cannot maybe use all the advantage that you can get from additive manufacturing in tool making, for example, conformal cooling, because in plastic tool this cooling is not so efficient as in metal tools.
Yes. So our approach is we will be using conventional mold base and other things like cavity insert and other things. That's a small pieces which we need customization. So what our approach is currently is we are having a common mold base, and we will be having that cavity area. In that cavity area, we will be putting different inserts, maybe SLA printed and other things, and trying for that molding. That's because printing a mold base itself is very time consuming. It's very difficult. So this is the approach currently we are trying.
Okay.
That clear?
Yeah. We have another participant here.
Yes.
Okay.
Narant?
Okay. You hear me? Shall I start?
Yes. Yes.
Okay.
Here.
Okay. My name is Nanon Noprat. I am a PhD student at Lund University in Sweden, and my research topic is about business models and additive manufacturing. So pretty much the topics of this workshop today. So I want to hear about what people are doing about on the additive manufacturing, and especially about the business model, because there's not many people who are talking about these topics. There's really, I think, a few research papers addressing the business models and the additive manufacturing. So I think it's has a lot of potential in terms of research and possibilities. And yeah, and I think one of my questions is okay, we have a lot of technologies, and 3D printing and additive manufacturing has been around for maybe 30, 40 years, and we still don't really see that many business models in the market, right? We have a lot of people producing machines and sell it. I think very few of them, lease or renting their machines. And yeah, there can be many more. And maybe one question is why, and then if we think about what else can we do, and if we change business models, how will it influence the development of new type of machines maybe. Yep. So I think that's pretty much what I want to hear. I'm looking for. Yep.
One thing I would like to comment on that, and I think probably linked to our first participant too, is when I prepared this slide, I have to admit that I tend to look at it more from a product point of view, but from the engineering and manufacturing side of things, there's a lot of exciting things. A lot of designer and probably engineer to a certain degree haven't quite looked at it from a rapid tooling point of view, haven't seen, didn't really think about this as a tool as much. They think of it as, something that produces the entire, object rather than parts of the object that will become, the insert, part of the mold and stuff like that. Once you start to get this into the idea that, your design can be changed very easily, if you think like this from the start. And not many of them think like this from the start. They always think, if I invest in injection molding, that's quite, a heavy investments and so on. I have to make the most of, whatever tool I produce, rather than see it as in, this tool I can change very, very easily with all these different parts, different things that I can add to it. And a lot of the time it's about the mindset of the people. Unless you change the mindset of the people when they start designing it, the actual machine are not changing because they're still using it in the very conventional way. You almost have to tell them, you know what, there's a new possibility. You don't have to stick to that way of thinking anymore. Think differently. And then you can make, better use of this technology. So I think, the area that both of you working on is really exciting.
Okay, thank you.
Question in chat, and I asked participants to maybe specify because it's not a clear question for me, at least for me. Are there potential small-scale uses for this technology that anyone knows of? But I'm not sure at which technology participant meant. Maybe generally additive technologies or specific technology from this field is not clear for me. General AM technology, small scale uses.
You have a very cheap version of it.
Yeah.
Very, very affordable that you can have in the primary school. Very easy to use, doesn't cost that much at all. Nowadays, in design school, when we have students come to the open day, this is when they apply, for the place in the university. In their portfolio, some of them have 3D printer at home. So they create something simple and print it at home. So you can buy a starter pack quite easily.
I said with the video. Okay. I'm not sure.
Anyone else would like to join the conversation, introduce yourself and say a bit about what you expect from the workshop? Otherwise, we would like to ask you the very first question, which you will see here. As we say, the customer is at the heart of all business model. So the question we would like everyone to think about is who might be the mainstream user of additive manufacturing technologies in the future? Do you think that it will be the user? People getting used to technology, nowadays you look around your home, everything is smart. Your speaker is smart, your fridge is smart, your doorbell is smart, everything is, integrated with other technology. They used to, operate all these sophisticated, products. So it might be the end user, or you might think, oh, it's a business. And it might be the business that appreciate, having a machine, to do these kind of things. It might be food producer, or it might be people in pharmaceuticals or anything else that might, worry about the risk of contamination and would rather have machine rather than workers. It might be the businesses that, could benefit from a very large scale 3D printing, that rather than have lots and lots of staff on site, you have these 3D printers, and you might be able to achieve whatever you would like to achieve in a quicker and hopefully more efficient. You might see it go more into educational institute. More and more, anyone who provide like teaching and learning experience are likely to have this machine. Or maybe you think about other, like it might go into production line more, as in, like a fusion between traditional way of producing things and the new way of producing things. So while you think about all this potential mainstream user, I think I'm going to answer Quick question about quality assurance. It is really depend on what technology you use. Each of them come with their own pros and cons, and the quality varies significantly depending on the material that you use and what you use it for as well. If you use it to make prototype, you don't require, that great quality control compared to if you use it as a spare part. That's quality control become a more serious matter. Then we might want to comment on this too. Or do you have any comments on this, Israt? Quality assurance with AM?
If I may comment on quality assurance with IM, just a short personal note. I'm familiar with the work of LTU of Luleå University of Technology in Sweden. Their product innovation division is currently conducting quite a large-scale survey with GKN Sweden on quality assurance of metal parts. It's quite a specific area where their PhD students are currently working on investigating different non-destructive testing methodologies and technologies to investigate how can we ensure that each metal printed part is suitable for such application in space industry where there is simply no room for error. So it's quite tricky thing due to porosity of materials. Radiographic and ultrasound testing is not suitable, at least not at the moment. And they are currently investigating various different approaches how to tackle this problem.
Right. So can we come back to the question that we posed to all of you? Could you let us know what you think about it? It might not be the choice that we gave you, we just come up with a few ideas of what is possible. But it'd be nice to hear from you what you think the future of, the future user of the AMX technology. And from there, then we can start thinking what might be the best or more appropriate business model for them.
Okay, may I? I think if we talk about end users, here is my thought, and I would love to hear your comments on. I think when it comes to additive manufacturing, we have to talk about the product, the additive manufacturers product. So it's like, let's say, a 3D printed product, right? So this is the product goes to the end users, and I think when it comes to the end product, I think it can be anyone. Like it's gonna be hard to imagine like who's not gonna use this kind of products. I mean, we might be using one of them right now, and we don't even know if like we are using 3D printed products or AM products, right? So I think in that case it can be anyone. But when we talk about 3D, additive manufacturing, AM technologies, I think it depends a lot on how sophisticated and how difficult to use the technology itself right now. Right now, I think we have a very wide range of the additive manufacturing technologies, from the home printer, really simple, press button and you have it, and the big machine used in the industries, and anyway, regardless of the machines, you still need this knowledge of how to design, how to work with the CAD files, how how to understand like where the product needs support materials and in what direction you want to print your products, so on. So I think once in a way this has become a barrier, maybe. I mean, if the design process and the process of transforming the informations and data, I mean 3D data from anywhere and convert it to the something that machines can understand to make it into STL files. If this becomes so much easier, I think we will have a lot of like more customer in the future, and it might remove the middleman. It might remove the manufacturer, the service provider in the middle, because like if it becomes so much that simple, I mean anyone can have the machines, and I mean any manufacturers can stop selling the machines and just print out their product and sell the product to the customers without needing the middle service providers. I think that's how I see it.
Anyone else would like to comment on this?
Yeah. I got another thing, like we were talking about the end users, especially about the smart products. When we are talking about the smart products, it's all about having a mechanical enclosure or mechanical things plus the electronics or the PCB or other things is coming. So right now we are trying to make the smart products like smartphones as compact as possible. So if additive manufacturing gets an option, something like that PCB or electronic components also getting added or embedded into the plastic enclosure itself. So this is some area which we have to think about, something like that. If copper can, because we have the DMLS technology, we have the plastic technology. So if technologies can be integrated together, we can clad plastic and the copper all thing together, and we can think about even putting the components also. Like currently that antennas, RF antennas is already embedded into the plastic. Similar way, in the additive manufacturing also, if we have the options to integrate the electronic components also into that plastic itself, I think that will be a huge advantage over the space and making the product compact. We found that there are some studies going on that one to put some capacitor or electronic components also into the plastic and do that one. It's basically that layer-wise welding and the different types of operation. These are the studies going on that one. I think this have a future. Like we all are trying to make compact products, and if we have some options to integrate mechanical and electronics together in additive manufacturing, that will be having a sure potential for the future. What do you think?
I really think that I mean, I can't comment much from the technical point of view, but from the user point of view, there is a clear trend in terms of people want to use their leisure time more productively. You know, in the past, people spend their time watching televisions. Nowadays, they create YouTube video. That's very different. You know, that they want to produce something and they enjoy, you know, having this kind of creative experience. It's something that they would like to do it kind of themselves. So this idea of people, you know, learning sophisticated technology in order to create something, so it's quite amazing if you think about how much they have to learn about video editing and so on in order to, you know, put a lot of all these things together. So to learn, you know, new technology is not beyond them, provide that, you know, it's the software or, you know, or this design is, you know, created from a user perspective. This idea of, you know, be able to create something themselves in a 3D form, you start to see more and more too. You know, when you have a look at things like, for example, Nintendo Switch, which is, you know, things for like, you know, it's a game console for children, but they're also the producing elements. You can make certain part yourself, and this idea of, you know, personalization, customization kind of coming through. So in the future, you will see that younger generation would love to do more of this. You know, they not just want to buy things off the shelf, they want to buy things off the shelf that they can continue to customize and personalize further. Nowadays, you could practically create nearly all the 2D artwork yourself quite easily. There's a software that allows you to do that. You can create your own magazine, your website, your card, your book, whatever, very, very easily, because 2D is a lot simpler. And by provide this very easy to use software, people can create practically anything. You can't quite achieve the same level with the 3D yet, but I'm sure that it's something along the way. And children nowadays also learn coding. It's a national curriculum of many countries now. So imagine in the future, you understand this part, you understand electronic part, you understand programming part, you will be able to do all this yourself. You can buy a lot of simple thing off the shelf, plus a few customization. Now, Anon mentioned about, this quality of, the finished products and stuff like that. Things gets a lot better. It's still not perfect yet. You can't quite get, the polish finishing, same as, you're getting product from a traditional kind of process, but things get a lot better and people are more tolerant to this a lot more. As they get used to plastic that is more plant-based, for example, which is not always as smooth as normal kind of plastic, you might have the new type of user that are more tolerant and more interested in getting something personalized. Doesn't have to be perfect, and sometimes imperfection is interesting. Combined with all this new technology, I think the consumer market is one of the big areas to go. But I wonder if anyone have other thoughts on other kind of type of consumer.
Can maybe I add something?
Yes, please.
Well, maybe my thoughts are, for example, in connection point A and point D, because think about the education of the younger generation, and if they will be educated enough in order to design a part, in order to use a different type of technologies, then they will be those end users who will use additive technologies to produce anything they want, anything that they imagine. So I can presume that point A is end user who will use additive manufacturing, not additive manufactured parts, because in that way he's user of technology, not of the printed part. So I think that A and D points are very, very connected. And on the other side, educational institutes must be prepared for a new generation with new curriculum, new way of learning, and we should already must change our thinking in order to be able to proceed our new knowledge about additive technologies to the younger persons. For example, the colleague already have compared injection molding with additive manufacturing, and injection molding have a lot of limitations. Okay. If you want to use the best of each of additive manufacturing technologies, then you also are not so unlimited in preparation of the parts if you want to optimize them. But you have more freedom than in any other conventional technology. And I also think about point C, because, but not only for about large-scale 3D printing, because today we have a lot of strong tools for optimization of parts for 3D printing, like topology optimization. And the main goal is to improve the performance of the part in order to reduce the cost, to reduce, for example, the fuel consumption if this part is used in airplane or in any kind of transportation mean. This is, I should say, main goal for the future: how to use as less as possible resources for a certain product and maintain the performance of this the product, or even improve it and produce it in a way that it was not again, we must go to the point D. We must learn people how to use the benefits of additive manufacturing and how to produce the parts that are really something quite new, and they should think outside of the box. We have really good exercise in London University, from which our colleague is coming also, with one maybe at first sight simple product, and we saw the traditional way of production of this kind of a manifold for company Atlas Copco, and after a few hours of our exercise, the guys from Land show us final product, and this is something quite different than anything that we knew before. So I think A, C, and D will be. It's not a simple question to your answer, but A, C, D, we in kind of a synergy can be main driver for future use of additive manufacturing. Of course, development of new materials is also a new technology, also very important. Yeah.
I really like this angle from sustainable viewpoint, because this technology, AM technology, have a very strong potential to use less material, consume less energy in producing things, because you don't need all this crazily big tool like some traditional way of producing something, especially when you deal with big parts, customized part too, when you mention things like airplane or ships or whatever, which is coming very large chunk. And when you think about the tool that they had to create, and AM technology could like create this part personalized, customized, with hopefully less material, less waste, and and make things hopefully a lot simpler too. So sustainability angle, very interesting. I really think that education is really the way to go. I think that the way that people think about a lot of these technologies and materials very different from how we see it in the past. However, when we think about end user, there also another trend which is very interesting, is this idea of access to rather than owning it. So it might not be that everyone owns this machine, but they have access to this machine very easily. It might be a place, a hub in the community where you could go and print things quite easily, but you don't have to have it at home. It will be a waste if everyone have to have one machine at home, compared to if you can share it, among certain group of people, and make a better use of this machine. Every time you print, you optimize what you print. It's more from sustainable point of view. I think that would be fantastic. I think we better move. Yep, please.
Just one remark. There is on YouTube, you can find a very funny movie, Fully Printed is the title of the movie, and I have it on as the last slide of my presentation about additive manufacturing, and it goes in the past, how the production was done in the past, how it is done now, and now the state of art is using so-called fabrication laboratories, fab labs. So you don't have to have a print at your home, but you somewhere in your town there is a fab lab when you can go with your CAD file and print, or ask someone to print the part. And in the future, you will buy a material, and you will go with this material to your home and print whatever you want. Okay, but it's quite a futuristic aspect of application of these technologies. The future will show us the real story. But yeah, you don't have to use your own printer. You don't have to own it. You can go to the certain spots, and I think that a lot of towns have this type of centers where you can come and print the part that you want.
Definitely. Right. I think we're going to move swiftly to probably, not the second question, the third question. So because we're looking at, like yes, this one is which business model you think would suit them best? Because we say at the moment the way it is done is you sell the machine, you kind of provide a bit of training, and that's it. Surely there's another way of doing this. Maybe it's it's all personalized, so it's not just you build off the shelf machine and anyone can buy. You build a machine specifically for the needs of your customer, or you might do something similar to photocopy machine, rather than the company have to buy this photocopy machine, they rent it, and all the materials and everything kind of is part of the rent. So you rent the machine, you have all these ink, papers and everything as part of it, and the company also obliged to kind of service it too. So the only thing you do is just pay for your subscription fee. Where you think it might be? You think that it will be a products and service? You think it will be more personalized? You think that it would change completely? It's not about owning a products anymore. It's about like access to AM technology.
May I comment on this question? Basically, my thoughts on this question is that it really depends on the industry and the type of user your product will aim. What I think that definitely is the future of consumer products in additive manufacturing is that people will own their own eye machines at home, and basically they will buy a machine or rent a machine, but they will also buy designs. So they will buy personalized designs and print them at home. They will not order them via Amazon or some other website, but rather they will contact the designer or use 3D scanning to personalize their own products and print them at home. So it will be some sort of on-demand production of personalized products. This is something that is still, I think that technology is still early for that, but the market will arrive in a few years. It just needs to achieve a critical mass of home printers, and it also needs to be some sort of a certified printers, because today we have a bunch of people that use FDM technology with different manufacturers and so on and so forth, and not every design is printable on every machine. So there will be some time in the future when we will have that kind of personalized product plus service in the sense that the service will be personalized design.
Totally agree. Anyone else would like to comment on this?
Yeah, I think I also I was thinking about like could it be something like the copy machines like you mentioned, because we know the evolutions of the business model used by the copying machines by Xerox, right? Like from the selling of the copy machines to people, and now they are renting and leasing and selling by the performance, like how much the user use it. So, but and I think that's possible too. I think it might, many different machines and different business models might coexist at the same time, I think, in the future. One business model that I think of is like televisions. So if you think about additive manufacturing as like a television, it's in the very beginning, I think in maybe 100 years ago, when not many people had televisions at home. They had to go out and watch cinemas and maybe looking at the funny machines, right? But they didn't have televisions at home. It took many years before people start to have televisions at home, and they can watch standardized programs like that air companies like BBC, so on. And it just in last 10 years that people were able to watch the almost fully customized TV programs like Netflix. So for example, like, I mean, in the future, you might have a really, really good and really safe standardized 3D printers, and people will want to buy it at home, like if televisions right now, right? And they can buy the designs from internet, like they buy from Netflix. Like they want the designs by these designers, and they purchase it from these designers. They have it printed at home, and they consume it like they watch Netflix. And it would be even better if there is a way to return this product if they don't want it, or they can, I mean, modify their designs. And it need to be a way to reward the designers, right? Because like right now, if you have an STL files, copy and print it anywhere, right? And you don't have to pay anything back to the designer. So the mechanisms how you pay back to the designers, I think will be an important driver how to make this this business going. So that's way of having a printer at home. But if you ask me, I wouldn't want to have a printer at home. I just want to consume the product. So if there is someone can print it for me and customize for me and send it to me when I want it, then I would be happy as well. So I think there can be many different business models.
That could be, yes, and actually that's where IBM is right now, because IBM used to be a hardware producer, but nowadays they're solution providers. So whoever wants solutions in terms of like computing and all that for their businesses, just contact IBM and we sort it out for you. But it's not about buying hardware from us anymore. That could be very interesting. So one-stop shopping. I just want this thing printed. I don't care how you do it, as long as you can get it to me, that's fine. And that might be another interesting way of looking at it. But as we all kind of agree that the end user could be important, education would be very important, and working with community designer would be very important. And I would say interface and software that will allow people, end user, to engage with the technology would be very important too. So hopefully in the future we see more collaboration between people who work in AM, more with educational institute, more with community of designer, more with the software provider, could make things a lot simpler for lay user to editing, CAD file, be able to purchase CAD file and print off whatever product they want, and through a lot easier. In the future, it might be a service where you could just click on anything that you would like to print, personalize it, and then click print, similar to how you order the personalized card nowadays. That could be very interesting too. Well, thank you very much for all your thoughts and and also joining us in this workshop today. I wonder if anything you would like to add, Israt? I noticed Eugene is back too. Are there anything you would like to add?
They have a really bad connection today because Israt and Eugene are not here at the moment.
Come and gone, yes. I had a problem earlier today. Now it's okay. I wonder if there's anything else, you would like to talk to all of us that we haven't touched upon yet. Oh, I think Israt is coming back. Not yet. Right, I would say if not, she's coming back. Hi, Israt.
Yeah. So
we're just going to ask you, are there anything else you would like to add?
So we almost a session, isn't it?
Yes, yes.
So ending. Don't have any further questions. Shall we request all the participants to give your valuable feedback for the what I've enjoyed? So I'm going to send you link in the chat box. So I would appreciate that if you all could fill in the form. It's a Google form link, and then send it back. Like it's just submit. You need to submit, entering your email addresses. So, Professor Godec, would you like to add anything?
It was very difficult to follow you. What have you said? I'm not sure. Does anyone else can hear you?
Oh, okay. So, anybody
Internet connection is quite slow, so we didn't hear everything you said. Better,
okay,
so
but what about now? Actually, I'm running. I think it's showing me my connection is going well. Okay. I can repeat it that I would appreciate that if you give your valuable feedback. So I'm going to send you a Google form link.
Right. I think I'll explain on behalf of Israt. She's going to send all of you some link for the survey to review the session. We'll be, appreciate your thoughts and your comments on this. But for us, thank you very much for joining the session. We hope you find it useful. And I'm, talking to all of you from a different kind of perspective, very, very interesting. So thank you very much for your contribution. And if you would like to, contact any of us for further discussions or any further questions, please do so. Thank you very much for your time.
Yep,
thank you.
Thank you also from my side, not only for the participants, but also to the team from Brunel University for organizing this workshop as one of the activity of our INEXADAM project. So thank you very much for organizing this, for preparing these interesting presentations, and then thank you for participants to be a part of our workshop. And as already Dr. Lan told you, if you will have any further question, do not hesitate to contact any of us. Oh, we now have a really good picture at the end, and maybe the voice also.
That's sorry. I apologize for dropping off repeatedly. I don't know what's the problem, but yeah, I have sent the feedback survey link in the chat box. I hope you have all can see, and please put your feedback in the form, and we would appreciate. Thank you.
Thank you, Israt, for preparing this. Thank you very much for all.
Thank you.
One question, Israt, do we need to play the functionally graded additive manufacturing a teaching case study video?
Oh yeah, yeah. The next after this workshop, so we will have a presentation. It's about functionally graded additive manufacturing, a teaching case study. So from our project, we it's a technical paper presentation. So after a 10 minutes break, we will be returning in this room again to play the presentation video for you guys. So please feel free to come back. Yes,
Okay.
Philip. We will do it. Yeah, after 10 minutes. So at 2 o'clock? And that means at 3 o'clock.
Okay, at 3 o'clock.
Central European time.
Okay.
Yeah. All right. Okay, thank you. Thank you, Dr. Lam. Thank you, Professor Godec. And thank you.
Thank you, Israt. And thank you, Dr. Lam.
Okay.
Hello, Israt. Can we continue with the session?
Hello, can you hear me, Philip?
Yes, I can hear you.
Okay, so my connection is, yeah, it's now good. Yeah, we can. I'm here actually, but my connection is just dropping off. Yeah.
Okay, so to all participants, now we will play the presentation of work presented by Israt and her team at the design conference.
Hello, everyone. My name is Rumana Kabir. I work at Brunel University, London, as a research associate in an EU-funded project called Onyx Atom. I'm going to talk about a teaching case study on functionally graded additive manufacturing conducted as a deliverable of the Onyx Atom. We'll start with a brief introduction of Onyx Atom project, moving to the main topic of functionally graded additive manufacturing and the workshop, how it is designed and utilized to find out the requirement in order to build a teaching framework. Onyx Atom is a 3-year European Union funded project. Is coordinated by the University of Zagreb, UNIZAC, and supported by the Brunel University London, UBrun, Lund University, LTH, University of Leuven, MU, and the Technology Institute on Metal Processing, Wood, Furniture, Packaging, and Related Industries, IDMA. The principal goal of this project is to widen the participation for collaborative research among the consortium partners and support the coordinating partner, UNIZAC, with technical assistance and knowledge in the field of additive manufacturing. FGM uses advanced additive technologies to build a single functional component, introducing materials and property gradients. This technology comes with several benefits. It can combine several properties and use diverse types of materials, gives design freedom, fast output, and shorter processing chain. However, it is a multidisciplinary area and still an expensive route for mass production. In spite of this, the emerging technology has attracted many existing and novel applications in aerospace, automotive, biomedical, and many other fields. The process consists of 3 main domains: design and modeling, manufacturing, and post-processing. The success to a quality output mainly depends on the 3 sub-steps, which are design of the parts, materials, allocations or gradations, and manufacturing description with the right choice of technology. An optimized relationship among these 3 stages is important to establish through research and educating the users within an appropriate framework. The aim of the FGM workshop was to help learners understand the concept and process chain of FGM. It helped them to recognize the benefits and challenges in the applications and design of FGM parts. The slides shows the teaching model applied for this workshop. The workshop was delivered as a combined teaching and assessment tool, including content-focused lecture, group discussion, and learners' activity. The participants informed the knowledge on design, manufacturing, and applications of FGM through the lecture. The group discussions were embedded in the lecture as a formative assessment tool. Learners' participation in an activity called FGM Project created an experiential and active learning. This provided an opportunity of summative assessment through a group flipchart presentation at the end of the activity. Finally, the triangulation method was carried out to validate the assessment of learning outcomes by an online survey by SurveyMonkey. The observation and analysis showed that group discussions helped to measure the existing knowledge of the participants and help the educator understand the need for further information. It also made the classroom more inclusive. Project group activity further helped learner gain good understanding in process, discover potential applications, and worked as a summative assessment tool to realize the fulfillment of learning outcome. Finally, the online survey results also helped to measure the level of fulfillment of the learning outcome and found out the learners' feedback on teaching, contents, and structure. As a concluding remark, it is understood that the workshop was the best tool to enable a small group of learners of academia to enhance knowledge on FGM. It identified the need for research and education of FGM to promote the technology to the Croatian industries. The teaching model successfully created an inclusive learning environment to fulfill the learning outcome to the adult learners. From this case study, it is understood that the curriculum has a great potential to attract a wider participants from both academia and industry by introducing practical sessions on current FGM technologies, design, and materials modeling for FGM. Thank you for listening. For further discussion and Q&A, we will meet in the panel discussion session. There is an announcement of our upcoming summer school on 29th of October, Thursday. The program will cover various interesting topics on topology optimization, material processing and design strategies for PBF technique, standards for additive manufacturing, and so on. For the details of the event, please visit our website. And for the registration, please contact myself or Professor Damir Godec by 28th October. Thank you.
Can you hear me, Israt?
Yeah, I can hear
Okay.
you.
So thank you very much for your presentation.
Can you hear me?
Yeah. Thank you very much for your presentation and for announcement of the summer school.
So shall we, I don't know, it's many people are left here, but shall we do the question answer here?
If you have a question, please ask.
Yeah, I can hear a few people are still here. So if you have any interest in knowing about our project and our teaching case studies and workshops, how we are doing, so please feel free to ask.
If there is no question, maybe we can close the session.
Okay.
Thank you very much, everyone who participated in this workshop. And thank you once again to the team from Brunel University for preparing all the presentations and interesting questions, which motivate at least few of participants to be active in some conversation with us and in exchanging some thoughts about future business models of additive manufacturing. Thank you very much to all of you.
Thank you.
Can you please answer the question posted in the chat? There is a question. Could you tell more detail?
For Nikita. Yes, sure.
You can answer by speaking, not necessarily by writing.
Well, so Nikita asked me that how we are going to analyze the survey results for the workshop. So the purpose of the survey is actually to understand the learning outcome being fulfilled, and by getting your answers, we would like to reflect on that, how we can improve our materials and any further requirement you have for our workshops in terms of information, in terms of workshop materials. That's the thing, so that we can improve our material further. So we're gonna qualitative analyze your questions and then publish a result. Yeah. You are welcome, Nikita. Thank you.
There are no other questions, as I can see. So now we really can close the session. Thank you once again, Israt.
Godec, and yeah, looking forward to our summer school then.
Me too. See you very soon. Bye.